Okay, so this is the third of the trilogy of these chapter 3 videos about the mole and using the concept of mole to in conjunction with chemical reactions to determine how much of things happen when things react. Okay, so let me pose a problem. Imagine that you have 230 grams of ethanol. You pour it out, and it's pure ethanol. You poured out 230 grams of ethanol into a beaker. And you're about to conduct an experiment, which is to try to find out when you burn that ethanol carefully, exactly how much carbon dioxide is produced, and exactly how much water is produced. Okay, that's the question that you're being asked to solve. Okay, so again, you have 230 grams of ethanol. And you're asked how much CO2 is produced and how much water is produced when you burn that much ethanol. Okay. Well, you'd be tempted to say maybe your first clue would be, well, okay, so for every ethanol for every one ethanol, you produce 2 carbon dioxides. So you'd be tempted to say that the answer for carbon dioxide is 230 times 2 equals 460 grams. You'd be tempted to say that anyway, wouldn't you? Because it kind of looks like you produce twice as much carbon dioxide as you do ethanol. That would be pretty incredibly wrong, however. And to demonstrate that, yeah, I won't be able to demonstrate that, but it is wrong, trust me on that. And the reason why is this equation is not talking about grams of ethanol, it's talking about molecules of ethanol. So 1 molecule of ethanol will produce 2 molecules of carbon dioxide. Or 1 mole of molecules of ethanol will produce 2 moles of carbon dioxide, 2 moles of carbon dioxide molecules. But not grams, but actual numbers of molecules. Okay, so that's not grams. So when you're given a problem or when you're given posed a problem where they tell you how many grams, you first have to convert the grams of ethanol, and you have to ask yourself, well, how many molecules is that, or how many moles of molecules is that? In order to determine that, you actually use what's known as the molecular, or the molar weight. What do they call it in the book? Atomic weight or molecular. Let me get the term because the term's important. Molar weight. Molecular mass. Molar mass. There you go. The molar mass. You use the molar mass of ethanol to figure out, given how many grams, how many moles is that. So what is the molar mass? Well, the molar mass is essentially you take all of the atomic masses of each of your elements. And again, the atomic masses you can find from the periodic table. The periodic table will show, for example, that the atomic mass of carbon is 12.01. Just for simplification, I'm just going to leave the 0.01 off. So the molar mass of ethanol is 2 times the atomic mass of carbon, 2 because we have 2 carbons in ethanol. It's 6 times the atomic mass of hydrogen, because we have 6 hydrogens in ethanol, and it's 1 times the atomic mass of oxygen. Okay. Well, again, looking up carbon is 12.01 in your periodic table. Looking up hydrogen, it's 1.008. Looking up oxygen, it's 16.00. So basically, this becomes 2 times 12. Can you still see that? Yeah. And this becomes 6 times 1. Again, I'm leaving off the decimal points. And this becomes 1 times 16. Okay. When you add all these up, that's 24 plus 16 is 40 plus 6 is 46. So the answer is the molecular mass of ethanol is 46 grams per mole. meaning if you had 1 mole, meaning 6.6 times 10 to the 23rd molecules of ethanol, it would add up to 46 grams. Okay, which is not very heavy, but that's like, it's like a large shot, like almost like a, well, like a good sized shot in a shot glass. Actually, probably a very good shot. Right. So for 230 grams of ethanol, how many moles is that? Well, the way you do that, I'm now gonna erase all this calculation, how we end up with 46 grams per mole. So if you have 230 grams of ethanol, we would then multiply this, I'm sorry, not multiply, divide this by 46 grams per mole. And if you get your little trusty calculator out, you'll find out that the answer is 5 moles. Exactly. That's why I chose 230. Okay. Now, this is something we'll talk about when we Skype, but we do this kind of unit calculation all the time, and it's basically pure algebra here. But we got grams divided by grams per mole, and the reason why it comes out 5 moles, and you always have to check yourself. In fact, you saw me just a second ago start to multiply, and I was, wait a minute, that's not multiplying, it's dividing. Had we actually multiplied 230 grams times 46 grams per mole, which would have been wrong, right? We'd have gotten a really big number when we multiplied that out with our calculator. But then we'd have to say, what are the units? And the units would have been grams times grams, grams squared, divided by mole. Again, the units that you use in your calculations are just as significant as the numbers are. And this is kind of one kind of key theme I wanted to call out. That I'm not sure if they do such a great job in the text at describing this. Grams squared per mole, of course, is not what we were after, and it's a clear sign that we've done something wrong in our calculation. Okay, but again, I really point that out, that it's really important to kind of think of these units almost like in algebra terms. It's almost like another variable, like an x kind of thing, that you would carry forward, and sometimes they cancel out and sometimes they don't. The way we drew this here, the grams didn't cancel like we had hoped, which is again a clear sign that we did the calculation wrong. However, if we do it like this, 230 grams divided by 46 grams per mole, the grams, the units, cancel out just like they would in algebra. And the mole, again, it's in the denominator, and it itself is in the denominator, and that's why it's kind of like 1 divided by 1 over x is x. Think about that in algebra terms. In this same way, the 1 divided by mole ends up with mole, in the same way that x ends up here. Okay. So anyway, I was long-winded, but I wanted to point it out because it's kind of important, especially when you get into calculations that use different units. Like if you had a problem that was given to you in pounds with one component and grams in another, you'd have to convert between grams and pounds. And it's important to actually keep the units in your calculations so that they cancel properly, so that you know you end up with the right answer. Okay, enough of that. So 230 grams is 5 moles. All right, now that helps us, because if we know that there's 5 moles of ethanol, we can actually redraw this equation in the way that I did earlier. Kind of multiply the entire thing by 5. Okay, and what we end up with then, I'll redraw that 230 in a second, is we end up with 5 ethanols, and 5 times 3, 15 oxygens, yields 5 times 2, 10 carbon dioxides, and 5 times 3, 15 waters. Okay, so again, they pose the problem. Suppose you had 230 grams of ethanol, how much carbon dioxide is produced? Well, now we know, because we know 230 grams is 5 moles of ethanol. And from our original equation, we know the at a molecular level what the ratios are of these components, and so we know that 5 moles, 5 molecules, or 5,000 molecules, or whatever you want to say, but 5 moles is what we're going to say right now, of ethanol produces 10 moles of carbon dioxide. So one of the questions was, how much carbon dioxide is produced? Well, the answer is it's 10 moles of CO2. But we want that in grams. So we're going to now multiply this by the molar mass of carbon dioxide, which is going to be some number of grams per mole, and that will give us our answer. All right. So what's the molar mass of carbon dioxide? Well, it has 1 carbon. That's 12.01, and it has 2 oxygens, each at 16. So 2 times 16 is 32, plus the 12, that's going to give 44. So the molar mass of CO2 is 44 grams per mole. The moles cancel, and our answer is 440 grams of CO2. So when you start with 230 grams of ethanol, you end up with 440 grams of CO2 once you burn it. Now let's do water. For water, we know that 5 moles of ethanol is going to yield 15 moles of water. Okay, so 15 moles, still see that? Yeah, of water times the molar mass of water in grams per mole. I'm going to erase my 42 just for the moment. Actually, what I'm going to do is I'm going to erase these. So I can put this up here. It's 440 grams of CO2. Okay, what's water? Water is 2 H's at 1 each. It's actually 1008. And 1 oxygen at 16. So that's basically 18, just to keep it simple. So the molar mass of water is 18 grams per mole. The moles cancel. And what we end up is 15 times 18, 100, 230, 270. 270 grams of water. So there's the answer to the question, which is if you burn 230 grams of ethanol, how much product do you end up with? Well, you end up with 440 grams of CO2 and 270 grams of water. That's the answer to the question. One thing I want to say though, or one follow-up is, cool, that's great, good answer. How much oxygen did you have to burn to make that happen? Well, we could go through the same process and say, well, it's 15 moles of oxygen would be the answer. We could calculate it all out, okay? But I'm actually going to do it a different way, which is we had 230 grams of ethanol plus some number of grams of oxygen, which yielded 440 grams of CO2 and 270 grams of water. One thing you can bet the ranch on is that the amount of grams that you started with here is going to equal the number of grams that you ended here, because mass is never created or destroyed in a chemical reaction. It is in a nuclear reaction, but not in a chemical reaction. So we could easily solve for x here just by adding this up. It's 710 minus 230 is 480. So the answer would be, for how much oxygen is needed to burn 230 grams of ethanol, the answer is 480 grams of oxygen. Okay. Now we could have arrived at that in a different way by taking 15 and multiplying it by the molecular weight, the molar mass of oxygen, which again is 2 times 16, 32. And if you multiply 15 times 32, you'll find out the answer is 480. So it's the same as you'd expect. Okay, 14 minutes, that was long. I better end it. But this was kind of the example I wanted to show about how mole is used and how it's actually used in conjunction with molar mass, which you can always look up from the periodic table to actually solve the question of how much is produced in a couple of reaction or how much is needed. Okay, that's all.